Hello and welcome to today's lesson on Longshore Drift. If you've not done one of these lessons before, I'll just explain quickly how it works. This is just as if you were in school. You're looking at the board as it would normally be in a classroom, and you're hearing me talk again just as it would normally be in a classroom. So the first thing you need to do is write today's title and date. The date today for me is the 9th of June. Might be a different date, put that different date down if it is. Underline your title and date please once you've done that. You see in the top right we've got a little green circle that says 5 min. That means the suggested amount of time you should spend on the do now activity is 5 minutes. If you need a little bit longer or you need a bit less, that's absolutely fine. The idea of these videos is that you pause them when you get to a writing task, complete that task, and then when you're ready you move on. But to give you an idea, it should take you about 5 minutes to complete these do now questions. If it takes longer, that's absolutely fine. Just keep it paused for a little bit longer. So there are quite a few questions up there which all link back to stuff you've covered in the past. If you're not sure of the answers, put down a guess, put down a go, and we'll go through the answers hopefully in about 5 minutes. If you need a bit longer, that's absolutely fine. Okay, so let's go through the answers to these questions. What is the part of the wave that moves towards the land called? So a wave, if you imagine it, comes towards the land, it crashes all over it with that sort of water, white bubbles. That part is called the swash. The water then returns sort of back out to the sea almost, as it looks like. That is what we call the backwash. So waves that have a very strong backwash, i.e. they're really strong going away from the land, but they're quite weak going towards the land, cause something to happen, and that is erosion, and as a result the beach or the land will get smaller. I'll explain this in a little bit more detail in just a second. Waves with a strong swash but a weak backwash cause what? So a wave that's really powerful going towards the land, but not that strong going away from the land, is going to cause deposition. So the beach or the land will get slightly bigger or grow. Finally, what powers a wave? That is mostly the wind. There are some other things too, like the moon, but we'll keep it simple and just stick with the wind for now. So let's go back to swashes and backwashes. Let's imagine we've got a beach here. The beach is the sandy bit at the top. The sea is the blue bit beneath that. The wind is blowing towards the land. Okay, the swash is the first bit of the wave that moves towards the land from the sea. Once that wave has crashed onto the beach, the water then returns sort of back to the sea, and that's what we call the backwash. Now we had two questions there. What if there's a really strong swash and a really weak backwash? If there's a really strong swash, that means lots of energy is going towards the beach and not much energy is coming back. So as a result, the wave is going to be really powerful going forwards, carrying lots of material, but then it's not going to have the energy to take all that material away with it. So as a result, we'll get deposition occurring. If it was the other way around, so say we've got a really weak swash, not a strong wave going forwards, but the wave picks up energy on the way back, then we're going to get erosion happening because the wave going forwards isn't carrying much material, it's not got much sand and rocks in it, but then when it comes back it's got lots of energy, so it's able to pick up more sand and material and take it with it. It's just the same process as we learned about with rivers. When a river has lots of energy, it's able to carry lots of material. The sea is exactly the same. When it's got lots of energy, it can carry lots of material. So if there's a strong swash, that means there's lots of material being carried forwards. If there's a strong backwash, that means that there's lots of material being carried backwards. It's when those two things, the swash and the backwash, become a bit imbalanced, that's when we start to get erosion or deposition happening in a noticeable way. This is quite complicated, I'm not going to lie to you, so if you need to go back and watch this all over again, that's absolutely fine, please do. When you're ready though, we're going to move on. So we're learning today about a process called Longshore Drift, and we're going to keep talking about swash and backwash to understand it. So let's imagine we have a bit of sand or a rock or some kind of particle, some kind of sediment, which is represented by that black dot. The wind is blowing the waves towards the beach, and as a result, the swash is carrying our bit of sand or rock onto the beach. That wave is taking it right there, and it crashes into the beach. the backwash will bring that material back out towards the sea, and it'll do so just like this. The swash will hit at an angle depending on which way the wind is blowing. If the wind's just blowing straight at the beach, then the swash will just hit straight at the beach. But in our example, the wind is blowing on an angle, and so as a result, the swash is going at an angle. But crucially, the backwash is always perpendicular, always sort of right angles to the beach. So the backwash is going to bring our bit of material, our sediment, back out into the sea. And then the swash is going to repeat the process, moving it down the beach like so. And so we're starting to see a zigzag pattern occurring where the swash is moving the material up the beach, the backwash is taking it back into the sea. But every time it does that, it's moving down the beach because the wind is on an angle. As we said, if the wind was blowing in the opposite direction, it would be moving the material in the opposite direction. But this is the process we call longshore drift. And essentially what longshore drift is a process where sediment is moved along the beach. And that happens because the swash and the backwash move it at a diagonal angle and then back down, and then at a diagonal angle and then back down. And so this means that overall there is a movement of material down the beach. So in my example, you can see that actually the beach is a bit bigger on the right hand side and a bit narrower on the left hand side because longshore drift has been happening. What I would like you to do is to make a copy or a kind of summary of this information. Now we've got two diagrams here. There's the one that I've explained, and there's this one here that I found on the internet somewhere. They're both quite good diagrams, and they both do have the key features of the labels of the swash, the backwash, and the prevailing wind as well. So I'd like you to make your own diagram, and I've suggested about 10 minutes to do this task. I'd like you to try and add some labels to it as well to explain the process that's going on. You can use either diagram. If you like this one, great, pause it now. If you don't and you want to use the other one, pause it now. Okay, so let's have a look at longshore drift in a bit more detail. Coastal processes like erosion, transportation, longshore drift cause different features. They make different things on the land, and we can see several features in these two photos. In the bottom, we've got Durdle Door, the kind of archway. That's a feature that's been created by erosion. Or we've also got a beach in that picture down there too. Again, that's a feature that's created by processes like erosion and transportation and deposition. I'd like you to add that purple text to your notes, please. It's a really important point, although I've just noticed there is a spelling mistake, so I'll let you figure that one out. It should take about 2 minutes to correct that letter O into whatever it should be and finish writing that down. Again, when you're ready, hit play. Okay, this feature here that we're looking at is something called a spit. I guess a little bit of an unfortunate name. And a spit is where actually over time the coast has grown, it's got larger due to processes like longshore drift and deposition. Now the first question I want to ask is, which way is longshore drift moving in this picture? Have a quick think in your head. The next question is, how did you know? Have a quick think in your head. Okay, if you think that longshore drift is moving material in this direction, you are absolutely correct. Well done. Why or how do we know that? Well, let's have a quick look at this. If we measure the width of the spit, and I realise, obviously, right at the back, that's a long way away. It's far away. Over here is closer, and so perspective, as I'm sure we all know from art, means that things that are far away look smaller, and so naturally it seems like, well, this is near the camera, therefore it's going to appear bigger. That's true, but if we look at the actual size of this, the purple arrows that are much closer to us are far larger than the ones that are further away. So longshore drift is moving material down the beach towards us, and we know that because the beach is wider and wider. Oh, sorry, wrong. The spit is wider and wider the closer we get to the camera. Regardless of perspective, there is a huge, huge difference between some of those purple arrows, the nearer ones and the further away ones. A spit then is a strip of land that is created by deposition. I'd like you to add that note to your exercise book or your paper, your computer, whatever it is that you're working on today for me, please. When you're ready, hit play. Okay, so this is what we call a lee, and that's where a spit actually covers a break in the coastline. And in this case, it's created a lake behind the spit. What's really interesting about this is that the sea is on the right hand side of the picture, and that's salt water, seawater. On the left, the lee, the lake itself, is actually fresh water. I've just realised I made a mistake, so I'm going to correct myself there. The lake is called a lee, the spit is actually called a bar instead. So the lake is the lee and the spit itself is the bar. Okay, so you've got fresh water on the left because it's being fed by rivers up here, and you've got seawater on the right, which is quite an unusual ecosystem for animals and plants and things like that to inhabit. You don't need to write anything down for this, just a bit of interest really. So let's have a look at how a spit is formed. We've got the wind blowing onto the land in the usual direction in this case. Winds never always blow in the same direction, but we have the kind of what we call the prevailing wind. You might have spotted that on one of the earlier diagrams. And the prevailing wind is the usual direction of the wind. It doesn't stay the same all the time, but it has a usual direction. In the UK, the wind tends to come from the southwest. So the wind is blowing onto the land, causing longshore drift to happen, and that means we've got material moving down the beach, and the beach is going to be getting larger on the right hand side. Well, now the coastline changes shape quite dramatically here, and so as a result the material that's moved down suddenly just gets dropped off because there isn't any more beach or land to push it onto, and so we get deposition occurring. And when deposition occurs, i.e. material sediment is dropped off, it starts to build up in this case, and so over time we start to see the formation of the spit, and it builds up over time due to the sea depositing or dropping off material right on the end of the coastline like that. What I would like you to do is to make a copy of this diagram. I would like you to title it Spit Formation. I'll say that again, Spit Formation. And I'd like you to try and explain the process that's going on here. Now, I think really there are three key labels, and I've put those 3 points where you need to describe what's happening. So two options here. If you want a bit of a challenge, you're going to pause the video in about 5 seconds, copy it, and then try and add your own labels. And then you're going to check your answers. I'd like everyone to have a go at that really, but if you're not sure, hit play in a second and you'll be able to see what labels I wrote. Okay, let's see, how did you do? So three labels I wrote are: number 1, longshore drift moves material along the beach. 2, deposition happens at that point. 3, this builds up over time, forming a spit. If you need to make any corrections or changes, please do those now. Okay, final question I want you to have a think about today is, would you want to buy a house on a spit? Why or why not? Just have a think for a minute. Okay, so this is a really interesting question, and there are lots of different answers, and as often the case in geography, there isn't necessarily a correct or an incorrect answer. There are certainly reasons why you would want to live there, and there are definitely reasons why I would not want to live there. You can actually see in the picture on the right there are some houses on there. The picture on the left there aren't houses, but there are plenty of boats and stuff tied up. So let's start off with the positives, some of the reasons you might have picked. You might say something like, well, actually, it looks fantastic. There are really lovely views of the sea. You get lots of fresh air. There's not going to be a whole lot of, pollution and cars and stuff driving around. It's going to be relatively peaceful. You obviously hear the waves and the sea, but at the same time it's probably not going to be filled with lots and lots of people, so that might be quite a nice thing to do. If you're someone who likes to go swimming or sailing or fishing, it's going to be a great place to live because you're right close by the sea. So some definite positives there. In terms of negatives and reasons why you might not want to live there, an obvious one is the fact that one day the waves may come and crash into your house, or actually one day the sea may erode away the spit. Spits can be there for a very long time. They can become permanent sort of parts of the coast, but there is still always that risk of becoming trapped by the sea, or the sea eroding away the land on which your house is built. What's more, they can be quite tricky to get to sometimes. You have a very long, narrow, thin strip of land. That means that it may be a long, narrow, thin road on which you have to drive along to get to the shops or to see your friends. So positives certainly, negatives as well. I'd like you to write down your overall opinion to this question as an answer in your exercise books. Again, pause this video and then when you're done, hit play. Okay, so this concludes today's lesson. Please make sure you've completed all the tasks. Remember, the great thing about these videos is you can always go back to the start and play them again. You can always pause them when you need to, and in the description I've added 2 links that kind of explain longshore drift and spit formation in a bit more detail. So if you didn't quite get it the first time, have a look at those 2 other video clips and they might explain it a bit better than I did, or in a way that is easier for you to understand. Thanks for watching. I hope this all made sense. If not, as always, please drop me an email, let me know. Also, if you can let me know what you find with regards to these lessons, is it easier when it's on YouTube or is it easier when it's on Show My Homework? It'd be really useful feedback. Have a good rest of your